Hello everyone, welcome to the webinar. My name is Clarisse. I'm part of the marketing team here in iBwave and I'm very glad to host this webinar today. So today we are going to talk about Public Safety 101 and I'm here with Alex Jovel, our sales engineering manager, who is going to walk you through the basics of designing a public safety network. So just before we get started, I want to cover up a couple housekeeping items. So the webinar will be recorded and sent to everyone after the presentation in the next couple of days. And also feel free to ask any questions to our presenter by using the GoToWebinar question box. We'll have a question and answer time at the end of the session. All right, so now we're all set. I'm going to hand the microphone off to Alex. Hi, Alex, how are you today?
Hi, Clarisse, how are you doing? Welcome, everybody.
Yeah, I'm good.
So as Clarisse mentioned, my name is Alex Jovel. I'm the Sales Engineering Manager for the Americas here at iBwave. I have over 20 years of experience in RF, working in the past for operators and OEMs, and close to, it's almost going to be 10 years here at iBwave. So today, the goal here is to give a quick overview on how to do a basics of a BDA passive design, which is kind of like the majority of the cases here in the US. Before that, we'll talk a little bit about our public solution offering, some of the challenges from an RS perspective. We'll have a Q&A session at the end, but before that, we'll have Clarisse talk a little bit about our certification program and a special promotion that we have going on. So who is iBwave? iBwave, we make software solutions for the design, planning, documentation of both wireless and wireline and building networks. We currently make solutions for PC, server, and mobile platforms, and we have a large presence worldwide. You could see on here that we integrate with most third-party data collection tools, and we have a large database of components. When it comes to public safety, really our focus is trying to help out on the full life cycle, right? So we have a management platform called iBwave Unity. Here is a location where you can store your projects, get intelligence. So you can imagine how important this is for public safety, where you have to do yearly tests. Our main focus today is going to be about the center solution that you see here, which is our PC version that works on for public safety. And we have our mobile platform that you can use pre and post installation. And as mentioned earlier, it integrates with most third-party data collection tools. You can just go on to iBwave.com and see which are the tools that we integrate there. So that's a really quick overview on our solution. Now let's talk about some of the considerations you have to take into account when doing a public safety design. So the first thing we have to do is we have to determine whether we need a system or not, right? So, and this is going to be determined through ASJ. ASJ is your authority having jurisdiction. These are going to be the folks that are going to determine what kind of system you need. And honestly, in a lot of cases, they require a system. For example, if a new building is coming up, in order for you to get a certificate of occupancy, you're going to have a public system working there, right? When it comes to the RF point of view, depending on the size of the building, it's going to determine what kind of solution. So it's very common on smaller size buildings to use things like repeaters, which is going to be our focus today. When you start getting into bigger buildings, you might have to use something like a active DAS. The benefit there is that you're using fiber. You could run it over longer distances and you don't have the same loss as if you were using coax, right? An important thing to mention is that we do have a heat map called interpolation signal strength, which allows you to take that outdoor signal into account and see, taking the materials you have inside of the building, what kind of coverage you have without a system. So you could use that to determine whether you have good coverage or not. But most of the cases, you are going to need a system for your public safety venue. So at the end, you have mostly passive and active, with the majority being passive. So that's going to be that's the reason why our focus today is doing a simple BDA design. When we get into that conversation about repeaters and BDAs, especially in public safety, it's important to note the difference between, so this is something you'll hear very common, what's a Class A and a Class B. So class A tend to be digital. You could do channel filtering. There are limitations to that as far as like the pass bands that you could have. Whereas a Class B repeater, usually, cost-wise, they're less expensive. But besides that, they're amplifying a whole band. That's the reason these used to cause a lot of issues. Now they improved. A lot of them have to have some kind of automatic gain control to control that. But you could see, I've heard of cases, for example, there's a FirstNet site that came on site causing interference. They don't know what the issue is, and it came down to a Class B. So both have pluses and negatives, but it's important to understand the differences when working with public safety designs. Now, let's talk a little bit about our RF design. So the challenges that you usually have when doing a public safety design, right? So the very first thing, and when we would do different polls with the different AHJs, they tell us that 80 to 90 of the designs that are submitted are being rejected. So some of these might be related to RF. It's important to note that the code has a lot of things that we're not covering today. Our focus today is going to be a little bit more on RF. So knowing that information is very important. What is it that you're going to be amplifying in your system? Very important to know that, right? The second challenge that we usually hear about is not knowing building materials. Nowadays, for example, if we're turning on a new building, it's very common for that glass it's energy efficient, but it also blocks the RF. Not only that, but knowing how concrete and all these different materials inside of your building might affect the RF is also very important. And what do you do in the cases where there is no building, right? If you can't go out there, for example, and take measurements, so also important to take that into the material that's going to be inside the building into account. And lastly, what's the impact if you don't have something that's good design, right? So if you talk to the majority of ASJs, one of the biggest pain points that they have is the impact of in building designs that are not designed well, most of the time causing some kind of uplink issues and bringing stuff down, right? So very a big problem when we're talking about first responders, and this is their lifeline, right? This is what their life depends on when they're going out into the field. So very important to also analyze the impact that your in-building system might have on the outdoor. If we look closer, so here in the US, the majority of the stuff revolves around NFPA and IFC standards. Those are the things, that's the code that's being followed. You could see from the screenshots here that there's other information on here that we're not covering, for example, things like having platinum rated cable, battery backup. But you see on here, there are a couple things related to RF, right? In particular, isolation and signal strength. So in the code, so first of all, you see that it spans from 2013, 2016, 2019. So code takes a while to be written and also takes a while to be implemented. But you could see as over time, you do have in the code for NFPA and IFC, something for isolation. This is 20 dB above system gain. We'll cover this, how you could do this in our software. And then you also see the requirement for signal strength and the area cover, right? So the area cover breaks down between general and critical. Critical is going to be your emergency hallways, your stairwells, right? So imagine areas that might not necessarily need coverage, but in the case of an emergency, that's where your fire department is going to be coming in, right? So, so we have a requirement for general areas and critical areas. And then you see also on here that we have something for DAQ. DAQ is delivered audio quality. So this is the way that you measure whether your voice is good or not. So subjective, people taking measurements and kind of grading it off a scale to see whether you have good DAQ or not. So, but on today's presentation, we're going to be focusing on signal strength here and the isolation. So when we look, so how, after you do your design, you do implementation, what are the things that you test for, right? We measured talking about doing DAQ measurements, but this is actually text from the code and things that you do post installation, right? So We talk about doing a grid test. This is how a grid test is done. You could see you have to overlay about 20 grids on the floor area. And then on each one of those grids in the center, you have to take a signal measurement. And you also do your measurement for DAQ. So this is the way that you validate whether your system could pass or not pass, right? And we have ways of validating this with our mobile platform, and integration with that third-party collection tool makes it very easy to do this testing. Okay, so that's a little bit on the RF considerations. Now let's talk about how some of the basic steps that you would do to do a design on our tool. So very high level. Obviously, we're limited here by time, but what we would do in our software, the first thing you have to do is create a project. This is very important. This is where you handle your project settings. Then another important part is doing the building modeling. So the accuracy of the building modeling is going to affect your heat maps. And then we get into the actual network design. Like I said, we're going to focus here on doing a repeater design. So first you add, in our tool, you add a system. I'll go over how do you add and connect some of the components. We have a cool feature to do antenna balancing. So I'll cover that. Donor isolation. We just introduced features also for defining general and critical areas on one floor plan. I'll cover that. How to do a prediction for signal strength, signal leakage, and then some of the reports that we have. So I did mention that we just recently came out with a new release, and we're covering, you saw from the code, right? We have a 20 dB isolation. This is where we get the default value, but we have a way of validating that. The calculation is taking the count, the DAS feedback, and comparing it to the signal you see at your donor signal, and calculating your donor isolation from there. And just off the press, I mean, it's so recent, we just released it yesterday, but now on here, we could actually see who are the worst contributors to making sure that your donor antenna isolation is not being met. So this is something that we just introduced. The other thing that I wanted to highlight that we introduced, so before, if you wanted to see, for example, a prediction of your general and your critical area, you would have to run two separate predictions. Now, because we could see various compliancy areas in the same floor plan, we have the ability to see general and critical on one view. The other thing that we just recently added to, fresh off the press, is the ability to see this in our compliancy report. So this is something that we have. So after that, so let's go ahead and see how we would do this on our tool. So I mentioned the first thing we want to do is we want to go ahead and start a project. So to start a project, I'll go on here and select new. And it'll open up this window for project settings. As mentioned, this is a very important part. You could enter general information about the project, but more importantly, this is where we have our different parameters. For example, the resolution that we want, at what prediction height. Here under advanced, one of the things that's unique to our software is we could take prediction in between floors into account. So we have ability of doing that. But once we're done, we could just click on OK. And the first thing it'll open up a design plan, and it'll open up our floor plan. Our floor plan is what we're going to use to import, any kind of representation of a floor plan that we have, whether it's a CAD file, whether it's a PDF, any kind of image. We have the ability of doing that. And there's different ways of doing this, but I'm going to right click here and go to show plan properties. This is my floor number 1. And what I want to do here is select what my background image is going to be. And I'll just select the CAD file that I was using for this example. I'll import all the layers here. Click on convert. And then we have an engine, CAD engine. So it'll convert that same file that we were using and select that. And then I also set my scale. The scale is very important because this is how we calculate limb budget, and also how we calculate cable lengths. So if we want our building materials to be accurate, we want to make sure that this is set. And I'm set to meters here. Okay, so we did our scaling. We click on OK, and it'll bring us to this CAD engine here, where we could go ahead and select which layers we want to go ahead and import. We could go ahead and select the layer that we want to identify here on the right-hand side, and you could see it highlights it here on the left-hand side. In this case, what we're going to do is we're going to go ahead and import our doors and assign them to wood. We have some glass here, glass window, our exterior walls. Select as concrete, interior walls. We use plasterboard, partitions. So we give you access to 40 something different materials, all with their respective losses and properties, so you could do your prediction. And here for partition, go ahead and select drywall. So after that, we could import, proceed, and you could see we did a quick importation. If I were to go ahead and turn this on 3D, I could see that I already have something modeled. So very easy to model in our tool. The other things, so we did a quick importation. We could go ahead and add walls if we wanted on here. We could change heights if we so desired. And let's wait for my 3D viewer there. Okay, so while that finishes refreshing, let me go on here and mention some of the other things. I'll select first off the snap feature that makes it easy. But the other thing that we could also model is our floor, right? So we mentioned that we take into account prediction in between floors. So this is the loss for that. And I'll quickly highlight this. So you can tell it's very simple to do modeling. We have a bunch of different tools that help with all of this. And lastly, the other thing that we could also model is incline planes. So this would be, for example, used in the case of stairs. Very important, for example, in stadiums, if you want to go ahead and do that. And you could see on here, I could refresh here. Here are the incline planes and the floor that I have. If I wanted, especially in the cases where you have duplicating floor plans, I could right click on here and duplicate and, for example, build a building like that, right? So floor number 2, especially, for example, in hotels where floor plans tend to replicate themselves, this feature is very handy. So you could see it's very simple to model, right? So now let's go on to a more completed. So I did some modeling on here. I already take into account how many antennas I need and based on the size of my building. What I haven't defined on here is a system. So a system is what's going to be used to generate RRF in our design. And the way that we could do that, we could go on here under network design and go to add a system. We have a couple of different options, 4 different options. These first 2 are used in the case of repeaters. So measured RSSI would be the measure that you have at the top of your roof. And theoretical path, we do based on distance using free space loss to calculate to see, what your loss would be at that building. A generic signal source just to generate a signal source. And then the other thing that we have is you could actually pull the actual part. So for example, as we see more FirstNet being used in public safety, I think there's going to be more small cells being used. Small cell is something that we could also input on here. The only difference there is that that part would actually show in your bill of materials, whereas these 3 options that you see won't, right? So in our case here, since we're going to do a BDA, we're going to go ahead and select off-ferret measured RSSI. We'll say that at the top of our building here, our measurement is neg 60. Click on finish. And now I could add this into my design plan here. You could see on here I already have my Yagi. So connecting parts and adding components is very simple. We have our parts database. So for example, let's say I wanted to go ahead and make a connection between this Yagi and the repeater that I have here in my basement. I could go ahead and select my coax cable here and select it, right? And try to do the connection. You see, when I do this connection, it actually doesn't allow me to do that because you're trying to connect what's being defined as an input to an input. So the software will tell you and give you that information. In this case, for a Yagi, what we need to do is we actually need to associate it to the system. So what I could do is I could right click on here and associate antenna to systems. I could check it off to associate to the system that I just created. You could see this is where I'm setting my isolation threshold for this donor antenna also. I could click on OK. The minute I did that, you could see the icon change, right? So first it was a red dot, a solid dot. Now it's a red dot with a blue signal. That means now this is an output, right? So if I go back here and select my cable, I could go ahead and run it to the repeater that I have. I've already defined a riser. So we have a bunch of tools that make it easier to do cable management. For the sake of time, I'll just go ahead and run it. So now the other thing that we could do is, well, I have RF going on here. Let's go ahead and see what my calculations are, right? So I'll turn on my composite power. I could see my antennas, I have output power out of them. Maybe not as balanced I would want. So this is actually something very important when you're doing public safety. You want to make sure, or just a design in general, you want to make sure that your antennas are balanced, right? If not, especially in public safety, this is going to cause big issues when it comes to uplink. So we do have a feature here called an automation tool. Under automation tool, we have 3 options. One of them is called splitter balancing. So you could see we've added a couple of couplers on here, splitters. I could go on here, click on this plus sign and add a 5 dB, and I'll go ahead and apply this to all. And what it'll do, it'll automatically change splitters and couplers that you have and try to make sure that you have something a little bit more balanced. So you see the minute I did that, I have something a little bit more balanced. So now I'm ready to go ahead and generate my prediction. To generate my prediction, I could go under the prediction tab on here. Under output maps, I have my system here. I could click on this plus sign, and here would be signal strength. Actually, before I do this, let's go ahead and set up our general and critical areas, right? So I've identified 3 areas here as critical areas. So you could see this is my emergency exit. This is a critical area because this is where all my equipment's laying at. And what we do, you could see there's a little pink square around the area. So this is what I'm defining as a different area for my compliancy. The way to do that, here under prediction, we could click on area and then highlight. In this case, my lobby is also a critical area. Highlight my square, create this. And now I could go ahead and define a compliancy to this, right? So this is my critical area. Code says 99%. So I want to make sure that I cover that. I'll make sure this is enabled so I could see it when I run a prediction, right? So now we're ready to go ahead and run our prediction. So I'll run signal strength. We have a couple of different options here. Fast ray tracing is what we want to use. I don't have nothing in my roof, so I'll make sure here that I'm just running a prediction for 3 floors. And here under compliancy, so I want to set my compliancy for my general area, which is the rest of the floor, right? So -95, and we're saying, and this should be 90%. Click on OK. Yes. And we could go ahead and run the prediction. The prediction might take a little bit longer because I do have it set to 1 floor above and 1 floor below. So there it goes. I close here. Now I could see, in the case here, you could see I'm passing my critical areas, and you could also see general here, we're passing the criteria for everything, right? So it looks like we're good. The other thing that we want to do is we want to validate our donor antenna isolation. So if I check this off and I click on validate, and this is what we just added, right? So we can show the worst contributors. And we see that we're not passing, right? And where the biggest contributors are, right? And surprisingly, some of them are in our first floor, right? So it could be contribution going to the glass above. So we did say the other thing that's important to take into account is seeing how it affects the outdoor. So we have a way to set what we call signal leakage. So I could right click on my floor plan here for the first floor, set distance here, and I'll just set this to 200 feet. And I'll go on here and create a different prediction. Here under very specific, if we want to do signal leakage, we want to check here for apply a prediction to signal leakage area. Click on run. And you could see very quickly that our signal, especially in these areas where we have glass window, it's shooting outside. So there's a couple of things that we could do to improve our donor antenna isolation, right? I could change antennas, maybe use direction antennas to point inwards, right? Um, one, for the years, to save time. So just note that there are things that you could do to improve the isolation. In this case, I might have selected something that's a little too hot. So I'll go ahead and reduce the gain here on my repeater. Click on OK. Now let's validate our donor antenna isolation. We're good with that, right? So now that we changed, we see the up power. Let's go ahead and make sure that we're still good coverage-wise with what we're trying to do. So we can see here that we are meeting all of our requirements. I could move this. We see we're passing here, all passing our general areas. And if we're checking signal leakage, let me go ahead and rerun this. You can see we're better with our signal leakage. So again, there's other things that we can do to improve donor isolation. In this case, I just went on here and made some changes to my repeater. But real quickly, you could see I generated a design. I validated all my potential challenges. The other thing finally that we could do here is that we could go ahead and select, for example, different reports that we could generate. So we mentioned our compliance report, compliance area, and we'll select, all this information here so we could see the areas that we have. So this is actually something that we just introduced into the software itself. Now we could see what our compliance areas are going to be in a report format and whether you're passing them or not. So, and we have various other reports. For example, you have your link budget report that you could see, your equipment list report, which is your bill of materials. All these different reports could be exported to different format. It could be configured. So for example, if you wanted to add a company logo, we have the ability of doing that. I mentioned the compliance report, right? The output maps report. And then finally, for example, if we need to further validation, we could see our full design in 3D if we wanted to, right? So that covers high level of how you could do a BDA design. So hopefully everybody got a good understanding from that. And like I said, our solutions, our focus today was really around our PC version, but you could see we really try to focus on trying to help out on the full life cycle, right? So that's the reason why we have our mobile platform. That's the reason we integrate with those third-party collection tools, and that's the reason why we have Unity in the case you need to do those yearly tests. So we provide a solution for reliable networks. We provide documentations are very important, right? We mentioned that one of the biggest challenges is, submissions being rejected. We do accelerate time savings, cost savings too, because you're making sure you're not over designing, right? We did mention also a way to go ahead and take, for example, um, components into account and ensuring that you're compatible with third-party collection tools. So having said that, I'll hand it over back to Clarice so she could talk a little bit more about certification and mention a special promotion that we have going on.
Yes, thank you very much, Alex. So just a few words about our public safety certification. So it's a 3-day course to master the basics of in-building wireless designs for public safety projects. And as you can see here, it's a widely recognized certification with world-class instructors. You will study real-life examples as well as having a dedicated support to answer your questions. So just so you know, our next virtual class is from July 21st to July 23rd. So feel free to register if you're interested. We'd love to have you. And otherwise, we have sessions planned in August, October, and December. So all the dates are available on our website. And also, I have an exciting news on the next slide, if you can change. So as you mentioned, Alex, we're now offering a 15% discount on the public safety software, as well as the certification. So you just need to go on the store and use the promo code PS discount, and it will be valid during 4 weeks from now on. So all the details will be emailed to you with the recording of this webinar in the next few days. So we really hope you will enjoy this promotion. So now I think we are all good to move to the questions from the audience. So we have some time to answer it. That's great. And I think Alex will answer the questions better than me. So we can go to the questions. First of all, Alex, are there clear definitions of when a public safety network is a requirement, and what are they?
Thanks, Clarice. So usually that's defined by county and the respective ASJ, as we mentioned, right? So from our experience in a lot of counties, if you're having a new building, it needs to have a public safety system. It's required by the property owner. So if you want the property owner to receive a certificate of occupancy, they need to have a system. Having said that, like I mentioned during the presentation, we do have a heat map called interpolation of signal strength that allows you to see what the existing coverage might be prior to doing an installation. So, but those would be, the clear requirements. So it depends on the county. So that's where we mentioned it's important to check with the respective ASJ. And as mentioned, you're going to be following most of the cases code related to NFPA or IFC.
All right. The next question I have for you is how is existing network coverage data captured, and how is a public safety network tested post-deployment and as part of acceptance?
Okay, so there are a lot of third-party vendors that specialize already on data collection. So we have a way, as mentioning, to integrate with some of those platforms seamlessly using our mobile solution. And as I said earlier, you could go on our website and see, which are the vendors that, which models and what vendors we actually interact with. So you could use this to capture walk test data and run in, like I said, this interpolation signal strength heat map to determine whether you have acceptable coverage in the field, right? Usually what's done post deployment, as mentioned during the presentation when we were talking about that specific writing for NFPA and IFC, you usually have a requirement to do some kind of what's called a grid test. And in that case, you're taking a floor plan, you're dividing that floor plan into 12 equal squares. And at the center of each of those, you're taking a measurement for your signal strength. And as I mentioned earlier, you're also measuring DAQ. So, I mean, in my opinion, though, DAQ, it's very subjective, right? Because it's two people, talking to each other. You say a couple phrases, and do you hear me now, and that kind of stuff, right? And you kind of give it a grade. So to me, that's very subjective. And as we're getting more, so the transition that you're still seeing a lot of public safety using radio, and slowly transitioning to FirstNet or other competitive networks that provide that data. So I think in the future there's going to be probably other requirements related to signal to noise ratio, because this you could kind of correlate it to data speeds. So but that's today that's how you're measuring existing coverage using the third-party connection tool, and then post deployment you're doing a grid test.
All right, thank you, Alex. And we also got some live questions about the DAQ. So I have one from Adam. He's asking, are there any predictive maps in iBwave that can estimate DAQ prior to site testing after system installation?
No, so like I was mentioning earlier, DAQ, it's in the code today. To me, it's subjective, right? Because there's a human error element there. The way you hear audio for men, right? Also depends on how old you are, right? So a lot of things like that. I think the closest thing that we have that could kind of give you a perspective into how good your quality is going to be is our SNR, and we do offer that as part of the public safety offering. So you will have an access to that heat map, and as mentioned earlier, going forward, as we see this transition, from going like P25 LMR network to to using more data intensive like FirstNet and using more of that kind of stuff, I think we're going to see a change in requirements there.
All right, makes sense. The next question is, can public safety coexist with wireless service on the same DAS?
Okay, so this is a good question. I guess in theory, you have DAS products that support different bands. So you could have a DAS that supports both wireless, like commercial wireless, and public safety. But what happens in reality is that more than likely they're going to be separate, right? So first of all, you have different coverage requirements for both systems. If you talk about a major operator and they're installing a system somewhere, they're going to want to cover areas where the majority of people are at. So, for example, in a mall, your food court areas are going to be primary focus, right? But when you're talking about public safety, there's other areas that might not need coverage, things like stairwells, right? Equipment rooms, emergency exits, etc., that are a priority for public safety. So first of all, you have like different requirements there, right? And then I know in a lot of cases, in order to avoid the liability, they tend to have separate ones. So in theory, you can have one, I guess, to answer the question, they can coexist, but in reality, there's different criteria there that more than likely that they would be separate.
Mm-hmm. All right, thank you. Next, someone is asking about the applications of public safety in a 5G network. If you can say maybe a quick word about it.
Sure. Yeah. I mean, so if we go to any of these public safety conferences like APCO, IWCE, you're always going to be there's like always a buzzword, right, related to 5G, even in the operator world. But I think in order to evaluate that question, let's think about some of the benefits that 5G brings, right, and the different use cases. Especially when it comes to speeds, and I think more importantly, the latency that you have with 5G. So the latency on 5G is so good. I mean, you're able to enable things like video surveillance, vehicle-to-vehicle communications, real-time analytics are things that you could do over 5G because latency is so good, right? So you could think of the different opportunities, like the future of the firefighter being able to incorporate even things like AR for training. But yeah, I would say those are like the biggest things to be able to see real-time analytics because of the benefits in 5G when it comes to speed and latency. So having said that, I think it's slow to adopt, right? Even today, if you think of FirstNet, right? So FirstNet it comes from 9/11 Commission, right? And I think today uh, FirstNet is like 80-90% done, completed on macro, right? But how much time has gone by? So I think it's going to take time, even in the operator world, right, to get more into 5G. But the benefits are endless, especially when it comes to public safety.
All right, makes sense. The next question I have for you, will CBRS ever be used for public safety over tradition, UHF, VHF? And if so, how far out is this a reality?
Okay, so for the people that don't know CBRS is it's US. It's called the Citizens Broadband Radio Service, right? And if I'm not mistaken, it's a 150 megahertz on the 3.5 gigahertz band, and it's part of shared spectrum. So it's part of it's already being used by the U.S. government, so they get priority. And then they have like different tiers, right? So one of them is general access, which is already it's been available, and then the other one, part of that spectrum is called the priority access license. So this is the one that's I think it was supposed to be auctioned this month. It's been postponed because of COVID to next month. And one of the things that I've seen recently is like a list of the different entities that have applied for that spectrum. I don't recall seeing any like public safety, for example, like counties applying for that, right? So what I can see like public CBRS being used for is to enhance, for example, a security system, right, for a private enterprise. And I think there's already an OEM that does like push to talk radio over CBRS. But I don't think we're going to be seeing, for example, counties do that. I think it's going to be more of a private enterprise. And like I said, one of the use cases for CBRS is to enhance things that, for example, Wi-Fi might not do. So enhancing security and improving the public safety for maybe like a private enterprise. I could see CBRS being used for that. What we're seeing, I would say, more the traditional path for public safety is moving from their legacy networks and going more and using, for example, more FirstNet or some other kind of alternative, right? Because FirstNet is run by AT&T, but Verizon and T-Mobile are also making a push into this segment, right? And yeah, you do have radio, but any other device that you're using, if you're having some kind of emergency, you're going to be using it, right? To call 911, for example. So our first responder community loves their radios, and rightfully so. This is at the end of the day their lifeline, right? So their life depends on it. So I think adoption is a little bit slow going out to FirstNet, but I don't see, at least from my point of view, I don't see, for example, counties adopting this. I see more like, I say, private enterprise enhancing their own security, public safety, and using CBRS as a use case for that.
All right, thank you. I have a live question from Lawrence, who is asking the difference between iBwave design and iBwave public safety.
Yeah, that's a good question. So iBwave Design is our legacy product. When we first came out with that product, it supported low bands, right? VHF all the way up to 5 gigahertz. And then recently we support millimeter wave, obviously, for 5G. So all the way up to like 60 gigahertz, if I'm not mistaken. So what we've done, and it has everything, right? So design enterprise, LTE, I mean, Wi-Fi, it has all the different technologies. What we found for the public safety market is that we could improve our offering. At the same time, we're going to be improving on how we released better features for public safety, that being demonstrated by the antenna isolation and being able to do general and critical on the same floor plan. But public safety, so it's a subscription-based model, and it just supports the bands that you would use for public safety. So UHF, VHF, 800, SMR, as I did during the demo, FirstNet, and I think there's a standard there for using public safety on Wi-Fi that's also supported on there, if I'm not mistaken. So that's I would say that's the difference. So it's a little bit more catered for public safety subscription model versus having a platform that does everything.
Okay, great. Thank you for your clarification. I have another live question. Is assuming the client has accurate floor plans, what formats would the floor plans need to be imported into the iBwave program?
Okay, so during the demo I imported, right, a CAD file. So obviously we support CAD, and then we support any other kind of image file that you might have for that. So a PDF, JPEG, PNG, and any other kind of format. So there's cases, for example, where there is no floor plan. You go out to the field, you snap a picture of the emergency exit. You could import that and start drawing walls. The benefits, for example, in importing the CAD is on CAD you have different layers, and you could assign different materials to those layers. When you're importing in kind of an image format, you're assigning one material to that. So sometimes it makes sense, for example, to just import it an image and draw walls on top of that, because it's trash in, trash out. So if you have, for example, a PDF that's been a copy of a copy of a copy, and it has like a bunch of specs and it's not really good quality, and you import that as a wall, well, all those little specs are going to turn on into walls. So sometimes we spend a little bit more time cleaning that up versus, for example, importing it as an image and drawing walls on that. And we've done a lot of improvements in our software to improve drawing, like drawing curved walls, drawing incline planes a lot easier. So there's a lot of things that we've done usability wise over the last few releases to improve on that also.
Okay, good. We have a couple more questions, if you're okay. The next I have is from Lawrence again. What is the workstation requirement for iBwave Public Safety?
So I don't remember the requirements off the top of my head, but we have a little bit of time here. If we go on to iBwave.com and on our website, we will include all the requirements based on the type of projects that you're working on. So if you go here in the iBwave Public Safety, view technical requirements. So here you can see the software requirements, and then requirements, the minimum, and then the recommended ones if you're using doing larger projects, right? So that's a summary of the requirements that we have.
Okay, thank you. Maybe two more questions before we end the session. A question from Adam: is there any particular reason why would install the repeater so far from the donor antenna, reducing the SN?
I mean, it's gonna depend on the type of the building. Yeah, I guess in theory, if you could and you want to decrease that cable between your donor and repeater, you could put it one close to it that was like added. There's no
Right, I don't hear you very well. I'm not sure if it's just on my side. Can you hear me, Alex? Okay, yeah, the sound is not very good. So I think we got to end the session now. Anyway, we answered a lot of questions already. So thank you very much, Alex, for this great presentation. And thank you also to our attendees for joining us at today's webinar. And don't hesitate to contact us if you have any questions regarding this presentation or our products and the discounts. So I wish you a very nice rest of the day, and thanks again, Alex.